Okay, back to part E. This is a composite function. That's what this weird zero looks like is for. It's so that we don't get it confused with multiplication. But the old school way of looking at this is f of g of x, and I prefer this because it shows that g of x is clearly put inside of f. Now, the book talks a lot about input, output, and here's one place where it really makes sense. If we think about order of operations, I'm going to calculate g first, and then the result of g is going to get input into f. So I don't even have to build this composite function. All I have to do is calculate it in the correct order. So the first thing I'm going to do is calculate g of -2 and -5x minus 1. Except for I'm going to put in a -2 instead. And what do we get? We get -5x times -2. That's a positive 10 minus 1. It looks like I get a 9 out of that. So I'm going to take that 9 and put it into f, 2x plus 1. And now I'm running out of room here. 18 plus 1 is 19. So our final answer, f of g of -2 is 19. Okay, more composite functions. And I'm trying to show you a pretty broad range of problems because some kind of strange ones show up that I didn't really see in the homework assignment because they didn't have similar problems in the homework. Okay, so same idea here. I'm going to start because g is my inside function. It's the one to the right. And f being on the left-hand side is my outside function. I'm going to start with g of -2, which is 3 times -2 squared plus 4. -2 squared is 4. 3 times 4 is 12 plus 14 is 16. And the result of g of -2 is going to be my input to f. And we get 16. F of 16 is 16 to the 3rd power, which if you plug it into your calculator is 4096. Okay, I thought the second one was pretty strange. It's g of 2/3. Technically, that's kind of a recursive problem, but we can still do it. Since they're both g, it doesn't really matter which we start with, but the inside function, we're going to start with g of 2/3. And help me do my multiplication correctly. It looks like I get 4/3. And 5 in thirds, 5 times 3 is 15. So out of g of 2/3, it looks like I get 19/3. Now I'm going to take that result and put it straight back into g. So g of 19/3 is 2. And again, just being careful with my fraction work. And my final answer here, it looks like it's 53/3. Okay, moving on. Oh, this is an interesting problem, but it actually isn't too bad. So what they do is they give us our x values, okay, and they also give us the values of 2 functions at 1, 2, 3, 4, and 5. And then they're asking us to evaluate f of g of x and g of f of x. And you just have to, focus on the details when you're trying to do this off of a table. So let's take a look at x equals 1 and f of g of x. I think I wrote it in the old school way instead of f. Yeah, sorry about that. It's a habit. So what I'm going to start with is g of the inside function, g of 1. And looking at my table, at x equals 1, g is equal to 4. Okay, that's the first step. Now let's look at f of 4. So the result of my inside function is what we put into the outside function. So we go over to 4, f of 4 is 3. So f of g of 1 is going to be 3. Now let's take a look at it the other direction by looking at f of 1 first. So now we're doing that second part. F of 1, so again, we go to our table, we find the 1, we find the y value of f, and then we take that value and put it into g. So g of 2 is going to be 2. Okay, so what I'd like you to do is go ahead and attempt the rest of the table. Pause your video, do the rest of the table, and I will do the same, and then come back and check your answers. So pause. Okay, so this is what I got, and I have a couple of notes about working these problems. One is that it's really helpful, and it's set up exactly like the quiz online. It's really helpful that they're using 5 different numbers, because you know you got it wrong if you wind up with the same number more than once in any column. The other thing I like to do is I actually like to do the whole column of f of g of x and then the whole column of g of f of x, because I find it less confusing for my brain. So let's go ahead and let's stop this, and I'll see you on the next video.